Hi everyone, in today's lesson we're going to talk about how to sketch a graph given the equation of a polynomial in factored form. Now the way factored form works is that you're always starting off with f of x equals some k value times the factors. So it could be x minus a, x plus b, x minus c, etc., etc. Okay? So here's an example. So we have f of x equals negative x, x plus 1, x minus 2 to the fourth, and x minus 3. Now the k is a constant. It's a number. And this number, whether positive or negative, tells us about the end behavior. So this is just missing a parenthesis here. But the degree of this polynomial, if it was written out like this, say if it was written out y equals 2x to the fifth minus 3x squared plus 1, we know that the degree is the highest power, so we would say 5. So if it's written out in this factored form here, all you want to do is add up the powers of the parentheses. So here's a power of 1, here's a power of 1, and by the x is a power of 1. So we have 1, 2, 3, and 4 makes a degree of 7. Now, this x is not a constant. The constant is a number. So what's the number in front of the x? The number in front of the x is negative 1. So my k is negative 1. And that tells us about the end behavior. So because the degree is 7, that makes it odd. And because it's a negative 1, my end behavior would look something like this. Okay? Now there's just a few things that you need to remember. Even powers create what we call bouncing roots, and odd powers cut through the x-axis. So let me show you what I mean by that. So the first thing I want to do is graph this polynomial here. First things first, let's find the degree. So there's a power of 1 here. So if we add the 2 and the 1, we get a degree of 3. Okay, so the degree is odd. And that tells me that the end behavior will either look something like this, or it'll look something like this. Okay? So what is the leading coefficient in front of this x squared? Is it positive or is it negative? Well, it's positive because there's no negative there. So we're going to have end behavior that's like this. Because remember, this is the y equals positive x to the third. So that's going to model that end behavior. So as x approaches infinity, f of x goes to infinity. And as f of x, so this will put infinity here. And as f of x goes to negative infinity, then f of x goes to negative infinity as well. Okay, now when do the roots occur? That's basically what we need to know. So remember, when we are in factored form, we could set y equal to 0 and find the roots. So let's do a t-chart. We'll get x squared equals 0. Take the square root of both sides. X equals plus or minus 0, which is really just 1, 0. And then x minus 2 equals 0. So add 2. So my root is at 2. So I have over here now, real roots occur when x equals 0 and when x equals 2. So you can make a little set bracket for both of those. Now, we said before that roots will bounce if they have an even power. So at x squared, we're going to have a bouncing root. And I'll show you what that means in a minute. And roots will cut through the x-axis when I have an odd power. So I have an odd power here, so they'll cut through at x equals 2. So the first thing we want to do is graph our roots. So I have a root at 0 and a root at 2. So step 1 is to graph the roots. Step 2, end behavior. So we said that these are my two roots, so as x goes to infinity, so does f of x, so does y. So we're going to have this graph go up, and it's going to end down here, so this part is going to go down. Okay? And now whether we go up and back down or down and back up is where we have a bouncing root. So you see how the root bounces at 0? That means it's going to bounce off of the x-axis. So it's going to here bounce off and come back down. So we don't have to be exact, but we just have to bounce and go back up. Okay? That's just a sketch of what this thing will look like. And that's really about it. All right, now let's move on to the next one. Okay, so let's talk about number 2. What is the degree? So again, count the powers. 1, 2, plus these 4 makes a degree of 6, so it's even. And the leading coefficient is a negative, or -1. So that means I'm going to have end behavior that goes down, down. So both my f of x's or my y values shoot down to negative infinity. And now let's find our roots. You can just kind of imagine this. These are my t-charts here. This is going to be -1. This is going to be +2. And this is going to be +3. Now let's talk about this one for a minute. It's x minus 2 to the 4th. So wouldn't there technically be 4 of them? 4 of the same thing? So when I do a t-chart, I don't need to do 4 of them because I know that they're all going to be the same. So technically there are 4 roots at 2, but we're only going to write one of them. So the next thing to do is write down what the roots are. So the roots are x equals -1, 2, and 3, and graph them. So -1, 2, and 3. And do I have any bouncing roots? Well, look for even powers. So I know it's going to bounce at x equals 2, and at x equals -1 and 3, it's just going to cut straight through because they have odd powers. So now let's take care of our end behavior. So it goes down, down at the end. So down, down. And I have a bouncing root at 2 and cuts through, so cuts across, cuts through the x-axis at -1. So cuts through, goes to some value up here, and then comes back down. I will eventually tell you how to find what value it cuts through, but for right now, let's just guess and just say, okay, it's going to cut through, come back down, and what happens here? It bounces off of the x-axis at x equals 2. So instead of going straight down here and back up, it's going to bounce and then come back down. Alright, so that's what it would look like. We don't have to be specific. This is really just a sketch. The only thing that actually is really important is this y-intercept. And we actually can find it. And I'm going to show you how now. It's not here for parts A, B, and C, but I could just show you how to do it right now. So a y-intercept, we discussed, occurs when x equals 0. So let's write down how to find the y-intercept. So x equals 0. So y equals -0 plus 1, 0 minus 2 to the 4th, 0 minus 3. So here is my equation that I'm plugging in 0 for here and here and here. So notice how I did that. Now let's just do the math. So y equals -1, -2 to the 4th, and -3. So just put this into the calculator just the way you see it and get an answer. You should get y equals 48. So here, there's no way I'm going to be able to fit 48, so I could just write 0, 48 just to know where it goes. Okay? So take a minute, try number 3 by yourselves, and I will go over that one in class tomorrow. Have a good night.